Example 5 says we're spinning a spinner. So here's our spinner down here. These are 4 different colors. I know it's hard to tell, but inside the textbook, these are 4 different colors, like yellow, red, green, and yellow, red, green, and blue. So notice it's split in 4 equal sections. So it says each section of the spinner shown has the same area. So that's telling us they're split into 4 equal sections. The spinner is spun 20 times. The table shows the results. So this is the results of us physically doing an experiment and actually spinning the spinner 20 times and recording what happened. Okay, when we do that and we actually record what happened and we're like doing it in real life and these are the results, that's called the experimental probability, because we did an experiment to actually find out what happened. Now, the theoretical probability is what should happen mathematically. Okay, so if we want to know if these 4 colors are equal, then the theoretical probability is that 1 out of 4 spins should be each color, because they are 4 parts of it and they are equal areas, so we have an equal chance of it happening. So 1 out of every 4 spins is going to be yellow, red, green, or blue. So think of that in terms of 20. If I want to know out of 20, that means 5 out of every 20 should be each color. 5 should be yellow, 5 should be red, 5 should be green, 5 should be blue. And that's what should happen. So that's the theoretical probability. Theoretical probability is what should happen mathematically. Versus experimental probability is what happened in real life. Well, it says which color is the experimental probability on the table, the exact same as the theoretical probability. Well, out of 20 spins, we should have had 5 of each color. So red is the same in this experiment as it was in theory. So it should have been 5 out of 20. All right, and then over here on example 6, our research team finds that 368 out of the 490 crustaceans have ingested plastic. The types of crustaceans that ingested plastic are shown. Okay, so on this chart. The team randomly selects a crustacean that ingested plastic to demonstrate their findings. What is the probability that they choose a crayfish? Okay, so they randomly suggest a crustacean from this table. And so we want to know the probability that they choose a crayfish. Well, there are 84 crayfish right here. And if you needed to, you could add all of these up, but they did tell us that 368 animals ingested plastic, so we know it's out of 368. And so 84 out of 368, that simplifies to 21 out of 92, which is 0.228 or 22.8% chance that they choose a crayfish when they grab out of the kind of 368 animals that had ingested plastic. All right, if you want to stop the video now, you totally can. I'm just going to go back and grab this extra practice right here in case you need it. But if you feel fine about this and you don't want to watch it, it's totally okay. So on this one, on A, it says the probability that the sum is not 11, right? So we can find that by doing 1 minus the probability that the sum is 11, because that's a lot easier to count. So the number of die, back on this example right here, where the sum is 11, that happens, let's see here, with 5 and 6 and 6 and 5. So that's our 2 spots that happens. So it's 2 out of 36. 1 minus 2 out of 36 is 34 out of 36, which you can then simplify to 17 out of 18. Or if it asked you to put it as a decimal, you could do that and it'd be 0.944. So 94% chance that you're going to roll 2 dice and the sum will not be 11, which means it's only about a 6% chance it would be 11. Okay, let's go ahead and try the sum is greater than 3. I'm going to come down here to do this one. So the probability that the sum is greater than 3, you can do that, but that's a ton of numbers. So let's use a complement. Let's do 1 minus the probability of the opposite. The sum is less than or equal to 3, because that's a lot easier to find. All right, so we're looking for the sums that are less than or equal to 3. So that happens here. It's 2, this is 3, and 3. So that happens 3 times. So it'd be 1 minus 3 out of 36, which would leave us with 33 out of 36. Always reduce it. I get 11 out of 12. And that is about 0.917, or about 92% chance of getting a sum that is greater than 3. And I think using that table is really helpful.